Hi, Nicola. How are you? Would you mind introducing yourself?
Yes, David, I am Nicola Tunesi from Claind, a commercial park concerning gas generators, laboratory and industrial applications. Then today we are speaking about gas generators mainly for laboratory application. And in order to understand and see what are the different application field and what are the advantage offered from the Claind PSA technology and the Claind generators. Speaking about the applications where laboratory are using nitrogen generators. That actually organomation are using evaporators for solvent removal with nitrogen generators. However, sample prep compromise only a small portion of laboratory requirement of nitrogen. Then there are several other applications inclined as we split in two big families. One family we call low purity nitrogen generator, another family we call UHP, ultra high purity nitrogen generators. Two different application, two different type of nitrogen generators. It could be also two different technology to be used. We will speak later concerning when and where to use the specific technology. When we speak about low purity nitrogen generator, we speak about application that require normally purity from 95 to 99.5, 99.9. Typically, other than sample preparation, also glow box, but the main user are LCMS, liquid chromatography mass spectrometers application, where is compulsory to use nitrogen generators for this application with a flow that typically is going up to 20 or also 30, in some case also 50 liter per minute, then a high capacity to be generated. Then this is why is compulsory the use of nitrogen generators than cylinders or liquid nitrogen that are more expensive solution. Other application for low purity are some optical or spectrometers detectors, ELSD that are LC detectors, or IRFT, then air detectors, where they are looking for nitrogen and low purity. The most important thing is to don't have humidity and don't have CO2 inside the gas. In many cases, in IRFT is used also dried air without CO2. Nitrogen is welcome for this application. Other purities are for ultra high purity. The typical one is GC, where in gas chromatography nitrogen is used as carrier gas and makeup on flame ionization detector. But other application ICP for analysis where nitrogen is used to dress the plasma flame, and other application again glow box where there are high reactivity sample inside to be managed, or DSCs, or circular dichroism analyzer. These are the two big families where nitrogen is used. And then if you consider the technologies and then the application and the analyzer we were speaking, come on, many laboratories are using this kind of analyzers. That means that the majority of chemical laboratories, they are potentially our customers. They are using nitrogen gas. The main challenge is due to the fact that nitrogen generator is the mostly economic and the mostly, how to say, trouble-free operation for the user. In other words, in all these applications that we spoken before, users are called to continues to exchange nitrogen, cylinder or liquid. Call the gas supplier to supply a new cylinders. Take care about when cylinders are becoming empty and then a series of actions that means management of the gas. Anytime, sometime the gas supply is not pure enough and can happen in some cases. Cost matter. Any year is necessary to negotiate cost. Come on, is a series of these to use the gas supplier instead than to produce by themselves nitrogen through a nitrogen generator. When the user purchase a nitrogen generator, the only thing to do is making a maintenance. These operations are generally really easy and not so expensive, at least for Claind generators, because I understood that from peak focused on low technology and the maintenance, mostly important for them in order to make profit on maintenance. This is their focus. Of course, are not helping very much the gas generator or nitrogen generator market. Our philosophy is different. We need to give a customer easy life, less maintenance is possible, and cheaper maintenance when it is possible. And then two different diametrally opposite approach. And this is why many customers that try our solution, our generator, they prefer to continue with our proposals. This is the winning of the challenge that we prepared for the market. Mistake on nitrogen selection. This is one that I introduced you before, is one of the mostly mistake. Why? Because there are several considerations. The purity of nitrogen generators in terms of oxygen and moisture is very important, and this is the results of the technology used. Consider that Claind is known on the laboratory market to have developed one specific patent, the fast purity, in order to maintain high purity in a few minutes after the startup and maintain the high purity after long years, long time of operation. Other story is the purity of nitrogen, speaking about total hydrocarbons and why we can make our advice concerning hydrocarbons removal, because we are using simply the PSA technology. The technology cannot have oxygen and moisture at low level and cannot have hydrocarbons removal, because this technology, the membrane technology, is not removing well hydrocarbons and oxygen. After we will see what are the difference between PSA and membrane. The average life of the generator that depend compared in this case with other PSA technology that Peak and other Parker they are using, for example, is some consideration concerning the quality of carbon molecular sieve used. We have an history of more than 30 years selecting carbon molecular sieve. We made research, we made a patent on that. Then we are, in other words, we are not new on developing nitrogen generator at high efficiency and high purity. And in all this year, we met several proposals, and then we had the possibility to select specific carbon molecular sieve to do the job that we are looking for. Then high quality carbon molecular sieve to be used for ultra high purity nitrogen. Another matter is also the packaging technology, the packaging technique of the columns. The carbon molecular sieve can fall down into the column and then close the column. It doesn't matter. But we know very well that the PSA technology is flowing air in one side and then nitrogen and air in the other side continuously for life. What means that? It means that there are the potentiality of carbon molecular sieve movement inside to the column. And this is not good for the life of carbon molecular sieve and not good for the efficiency of carbon molecular sieve. Then our main job is also to fill and pack the columns using a specific technology in order to put the molecular sieve inside to the column, but introducing them in different direction. First in one direction, after in another, making vibration. Be sure that at the end of the packaging, molecular sieve are not moving inside due to the different flow of air and nitrogen into the column. In this case, we prevent that the movement of molecular sieve, we prevent that molecular sieve are generating powder, and then we prevent that molecular sieve are losing their efficiency. Also, this technology is something that, how to say, when you buy a nitrogen generator, some customers say, come on, there are two columns from them, two columns from here. Always are two columns. Yes, it's true. If you see only at the end, if you are looking to decrease the price, probably is one of some question or complaint you can make, but that two columns can be filled with different molecular sieve, with this different technology, and the two columns can be managed in the flow with a different managing system, different system controlling flow, timing, and so on in order to have the high purity. Then also the size of the column and the height and diameter are another important thing in order to develop and have the proper quantity of nitrogen produced. There are many things to say. Of course, the winner is who know better the technology. In this case, we can say that we know the technology. Probably there are other companies that they know very less this technology with molecular. And this is one speaking PSA and carbon molecular sieve concerning the maintenance request must be as low as possible in order to avoid machine downtime and high management cost. High management cost is very tricky system used from several suppliers. In other words, it's like to say printers where in the past the printers was costing very much. At the end, Hewlett Packard decided to sell at a very cheap price the printer and then sell at expensive price the inkjet in order to have business on that. The same is management cost, and then try to sell at low price the generator in order to have maintenance to be done and recover the profit from year by year by year by year. And some customer they prefer to buy at less price the generator and after continues to pay the maintenance. Good thing if they don't use so much the generator, very bad thing if they continue to use the generator like in the LCMS application. This is our consideration that generator need to work continuously, and then we develop a generator with inside not only a PSA with molecular sieve technology that is consuming less air than membrane, but also less maintenance and less compressor. Require less maintenance. Why? Because we are using compressor at high quality, a compressor that doesn't require continuously to be exchanged every 2000 or 4000 working hours. Our compressor inside, in the Model 45, for example, need to be exchanged the piston after 16,000 working hours. Then, yes, it's a little bit more than other compressor, but come on, is guaranteeing at least 4 or 5 working years before maintenance of compressor. And then this is the philosophy that to produce and develop our generator. Other than this, the remote control, when possible, which allow the nitrogen generator to be installed also in other room. And this is important because the space into the laboratory always is not enough. Where I place my generator, I place below the bench, I place in that corner, I place there. Oh, he's making too much noise. Anytime they are not happy. Okay, take the generator, place upstairs, downstairs, in another room, doesn't matter. Important is to know if it is working or not, if it is producing the right pressure or not, or the right purity or not, and then have the possibility to control it remotely by a PC is important. Some evaluation to do when nitrogen generator need to be purchased, and these are the point that we can ask at customer to take in consideration, because it's not only the price at the end is the last stage, because they need to do all this evaluation. The price is not only the price today, is the price today, next year, the year after again, at least for 3 years. In fact, we are winners where we are proposing our generator with 3 years maintenance, 3 years, 4 years maintenance. Peak, they are too expensive. Other companies also. Mistake on and do selection. If there are some questions, please interrupt me.
Will do.
This is the question that you asked. Oh, come on. Is better to use membrane or PSA? Membrane based and pressure swing adsorption are the two technologies used to produce nitrogen. Both. I cannot say membrane is not good and the best is molecular sieve, PSA, because are two different applications, two different technology, and can be used both for several applications. Membrane characteristics are very easy. Is a tube, doesn't need very much. Needs simply a pressure, air without condensation, and that's all. The purity is not an issue because they generate a low purity nitrogen, but where is necessary low purity? Why not? It's good. And then it doesn't require power supply, is another very big advantage in some case. And then is simply a filter that is taking compressed air, and then compressed air is split in humidity and oxygen and CO2 in one way, and nitrogen and argon in the other way. Low purity, low efficiency, but working well. Why not? We also are using membrane, for example, for into our Olympia series. Molecular sieve is another category, is another technology, is another category with that the PSA is using molecular sieve can be reached purity of 99.999%, then purity for up to GC grade from 97% or also less. Then very good technology to produce high purity, the only technology to produce high purity. Very good technology because she is consuming less air than membrane. And this is an interesting advantage. Very good technology because the lifetime of molecular sieve is highest than the membrane. PSA technology and hollow fiber membrane. Residual oxygen content. PSA can arrive up to GC grade 99.9, 5 ppm maximum. Membrane maximum is 99.5. Very good for CMS, very good for low purity application, but absolutely cannot be used for UHP application. Hollow fiber membrane cannot remove very much moisture. And this is another disadvantage. Some companies, they don't care about this topic, but come on. Minus 20 dew point means around 1000 ppm moisture. Minus 60 means about 40 ppm. That's totally different. It's true that is going into the interface, less moisture is inside, less maintenance you need to do with the quadruple on the detector for LC. Concerning total hydrocarbons, the molecular sieve are very active also with hydrocarbons, matter that hollow fiber membrane. Membrane are not active with hydrocarbons. If you want to take out hydrocarbon, you need to add a charcoal trap filter, and a small charcoal trap means that much less efficiency than a big column carbon molecular sieve like in the PSA. Another important thing to take in consideration is also the air-nitrogen ratio, how much air is necessary to produce nitrogen. The ratio of PSA at 99.5 is 2.8. The same ratio of 99.5 for membrane are up to 4.9. After there are also membrane that consume less, about 3 times, 3.5. But come on, again, you need to consider that molecular sieve are consuming much less air. Consuming much less air is very good. Low energy consumption for laboratory energy not so much a big consideration because the volume are small, much more important in the industry. But is very good to take in consideration because means smallest compressor and less maintenance. Then this another important point is to say molecular sieve working time is at least 10 years. We have generator that working for more than 20 years without problem. If customer do the proper maintenance, simply the proper maintenance, can work for a life with molecular sieve. Matter that with technology after 5, 6, 7 years need to be exchanged. No story. And this is the heart of the system. And be sure that is not cheap solution. As I introduced before, you can imagine that a proper CMS column, then other than cutoff and so on, prevent inlet air peak during the column switch. Then means that less air consumption and less peak means less stress of the molecular sieve due to the inlet consumption flow peak. And then less mechanical stress means less molecular sieve producing powder, less molecular sieve destroy, and longest life. Less inlet air consumption means energy saving, less maintenance on air filter and generators, and the maximum performance of carbon molecular sieve is a guarantee of a very good analysis, is a guarantee of less maintenance on the analyzer and a proper, pure and clean baseline into our chromatogram or into our mass spectrometer. Means improve nitrogen purity and very long lifetime solution advanced from the molecular sieve technology PSA we are proposing. Some products that we are proposing into this field is the Plinius series, that is with compressor inside, the Olympia series with compressor inside, or the Brezza line for GC ultra high purity for gas chromatography and ultra high purity generators. Now we've spoken before only on generator for a single application. application. But there are some laboratories that they are a lot of LCMS or sample preparation. And then they are a lot of flow in order to supply several LCMS or sample preparation. And then we supply, in case like this, what we call industrial generators into the laboratory. Series flow, series pico, series maxi or dominus. Doesn't matter. Depend the flow. Just to give you an idea, we supply Agilent demo lab in China, in Chengdu, in order to supply 15, 16 LCMS into their demo lab. But we supply another biotechnology company in China, in this case in the south part of China, supplying more than 30 LCMS. But we supplied several of these units in Germany at the TÜV company or in Italy in some big laboratories supplying sample preparation and LCMS generators. There is one laboratory that is called Lab Analysis, but also other laboratory like SynLab that is a multinational, that they are using a lot of nitrogen. In this case, we supplied several of these generators based in several lab plants in order to do the complete build nitrogen supply. Then also in this case, these are machines are without compressor inside, then are universal power supply and can be used without problems for sure. Also, this one have the remote control, and the remote control is helping very much the installation in some corners into the company, having the possibility to control what the generator is doing, what is the pressure, what is the maintenance requirements, what is, in this case, what is the purity, because the generator are including the purity analyzers and so on. That you can monitor what is the activity of the generator. Speaking about technology where PSA I already informed you, but there are also zero air with a platinum palladium catalytic reactor and the hydrogen generator. We have three technology, but we can speak later.
What are the best recommendations you have in terms of how a lab could best maintain their nitrogen generation equipment?
The most important thing on nitrogen generator with PSA is to supply clean air. If customer supply, if the generator is without compressor, if customer supply clean air, nitrogen generator can go on working for 15, 20 years without problems. It's like a mule. Is one product that is very easy, very long life, very reliable, and we have, just to give you an idea, we have a lot of experience on that. We supply also some gas companies, like Air Product, for example. They decided to buy from us the generators to supply nitrogen generators to their customers. In other words, it costs less to them buy a generator from us and install at their customer instead to produce gas and bring this gas to their customer. This is only the economical point of view, but is giving you the idea. If it is more convenient economically, is also more convenient on managing the distribution chain. Means that other than convenient at the beginning is also more convenient in the years. We supply to them more than 3,000 generators for beer dispensing. In England, they are drinking a lot of beer. And in their pub, they install this small wall mounting nitrogen generator. For them, it's better to do this. supplying only CO2 time to time, maintain the generator time to time. They have one person and half, one person part-time and one full-time person taking care about the maintenance of about 3,000 generators. Their people are going to customers to bring CO2 cylinders. Sometimes they exchange the generator to bring at home for maintenance, but this is what they do. It is giving you the idea of the reliability of the system producing nitrogen. And when the system is well maintained, technology is giving the possibility to go on for a long time.
That's great. I appreciate the time today. Thanks so much.